Okay, let's talk about sequences and series. First of all, a sequence is a list of numbers, and a series is the sum of a list of numbers. That's a little oversimplification here. Let's go through here real quick and give some definitions. Finite, it ends. Infinite, never ends. Convergent, divergent, we'll talk about that in a second. Recursive and explicit. Recursive would be something like this right here. A recursive formula has two sections to it. It tells you what the first term is and it tells you how to get the next term. Explicit would be everything within one formula. One other thing while we're at it, I'm going to write a couple things. The arithmetic sequence looks like arithmetic. This is when we are adding or subtracting. The same thing every time. We're adding a negative, so we'll just call it adding. And a geometric sequence is if we are multiplying by the same thing every time, or if we're dividing. But if we're dividing, we're really multiplying by the reciprocal. Like if we're taking half of it every time, we're not dividing by 2, we're multiplying by half. Okay, a convergent series, divergent series. I'm going to give you an oversimplified definition for these because for our purposes right now, this is all you're going to need. But when you get to higher level math, this is not necessarily going to be the case. But a convergent series gets closer to 0. And it's kind of killing me right now because that's actually not always the case. If it's geometric, so this is the case. So I'm going to put if it's geometric. By the way, there are series that are not arithmetic or geometric, like natural log, for example. If you do one like that, then that one gets closer to 0, but it does not converge. So that's why I threw this in here. Divergent series gets further away from 0. Further away from 0. Let me give you an example real quick. A convergent series would be something like 1, 1/2, 1/4. Actually, this is a convergent sequence because we're not adding them. 1/8, and it keeps going like that. So this is getting closer to 0. And by the way, in this case, R is 1/2. Where R, common ratio, we're multiplying by half every time. So R is 1/2. And a convergent series will get closer to 0. And the R value is less than 1. There's a little catch to that, actually. It could be between 1 and -1, so we can do that, actually, between 1 and -1. Another way of writing it, another equivalent way of writing it is this. R is less than 1, but we make that absolute value of R. There we go. Okay, the recursive formula for an arithmetic sequence is given below. Is the sequence arithmetic or geometric? Well, they told us, and I'm telling you right there. Look, see that plus sign right there? Because we're adding, it is arithmetic. What is the fifth term of the sequence? I don't know. I do know the first term, though. I know that the first term is -12, and we're going to add 3 every time. So we add 3. Second term, add 3. Third, add 3. Fourth term, add 3. Fifth term. So here it is. That's the fifth term. By the way, a more efficient way of writing it is a sub 5 equals 0. Find the sum of the first 24 terms. Okay, this is where the formulas are going to come in very handy. So you have a formula sheet on the very front of this, and we want to add together a whole bunch of stuff. We want to find the sum of an arithmetic sequence. We're going to write this formula down, and we're going to fill some numbers in. So it's the sum of so many numbers, and then n over 2, a1 plus an. There we go. Okay, well, we want to find the first 24. So the sum of the first 24 terms is 24 divided by 2. And a1, well, a1 is the first term, and they told us it was -12. an, well, an, the nth term, the 24th term, I don't know what that is, so we're going to leave that blank for a second. We're going to come over here, and we're going to find out what it is. So we don't know what the 24th term is, so we're going to use a formula for it. What formula are we going to use? Well, here we go. Find the 24th term of an arithmetic sequence, or to write the explicit formula, we'll use this right here. So we'll write that down. A1 plus n minus 1 multiplied by d. All these formulas will be on the front of your exam. negative 12, and then in this case, n is 24, so 24 minus 1, and then d. d is our common difference. It's what we are adding every time, and in this case, we are adding 3 every time. So we'll just work all that fantastic stuff out, so whatever 23 times 3 is, and then we subtract 12 from that. There we go, 57. That's great, 57, there we go, it's right here. So the 24th term is 57, and that's fantastic, but we're not done yet. We still don't know what the sum of the first 24 terms are, so we'll just type that in the calculator. So 24 divided by 2, obviously that's 12, multiplied by negative 12 plus 57, 540. There we go, 540. What is the explicit formula for this sequence? The explicit formula is the formula that will give us any given number. So it is this guy right here, which we actually just used. Any given term. If I wanted the 24th term, if I wanted the 100th term, whatever. So any term I want is the first term plus, we don't know what n is because we're going to plug it in. That's the whole point. Multiplied by 3. There we go. Now we could simplify that, and I'm going to, just in case some of your answer choices on the exam are like that. So let's bring this down a little bit. Negative 12, let's distribute the 3. So 3n minus 3, running out of room here, bring it over. Negative 12, negative 3 is negative 15, plus 3n, that is equal to an. There we go. This is the final answer. This is also a perfectly acceptable final answer. Okay, let's talk about Sam. Sam deposited $256 in his savings account. Each week he's going to deposit half of that amount he deposited the previous week. At this rate, how much will he have deposited in his account after 8 weeks? Before we go too far with this, let's go ahead and start making the list. He deposited $256. This is A1. You can call it A, you can call it B, you can call it whatever letter you want to. So then he deposited half of that, and that's going to be A2, and then he's going to deposit A3, and then A4, and we could go to 8, but I'm not going to for reasons I'll explain in a second. So he deposits half of that the next week. So half of 256 is 128, and then he deposits half of that, and then he deposits half of that, and we can stop there because we kind of have a firm grasp on what's going on. So let's kind of stare at this for a second and write down a couple things that we know. We do know that the first term is 256, which I'm not going to write that down. But we also know what we're doing every time. Are we adding or subtracting? Actually, neither. We're not adding or subtracting. We are dividing by 2, which is equivalent to multiplying by a half. So our common ratio, what we're multiplying by, is 1/2. So here's what we're going to do. We're going to find the account. The amount deposited in the account after 8 weeks. And again, we could go all the way to 8, but I'm going to use a formula just in case this number was crazy. If it was 127, then good grief, you don't want to do all that. You don't want to write them all down and add them all up. Let's use a formula. Sequences and series, arithmetic, no. Find the nth term, no, don't need a specific term. Sum of an arithmetic, no. Sum of a finite, this is finite. We're adding a set number of terms, not an infinite number of terms. Here we go, it's this one right here. Write the formula down, and then we'll plug some numbers in. S sub n equals A1, 1 minus r to the n over 1 minus r. And then I'm running out of space here, but that's okay. Let's fill some numbers in. We know what A1 is. It's 256. 1 minus 1/2. We'll put it in parentheses. To the n. Well, we're adding 8 things, because they said so after 8 weeks. Close those parentheses. And on the bottom we have 1 minus 1/2. We'll put that in parentheses as well. Type that whole thing in the calculator, and that will tell you how much money Sam deposited within 8 weeks. So 256, 1 minus, I'm going to use a decimal there, 0.5 to the 8th power, divided by 1 minus 1/2. He deposited $510. There we go. Let's use the same information as the previous problem. How much will he have in his account if he continues this indefinitely? Now, if he continues this indefinitely, he's going to be depositing fractions of a penny, so it becomes kind of impractical after a while, but we're going to go ahead and go with it anyway. Indefinitely is the same as infinitely, so it is A1, 1 minus r. There's your formula. It's the formula right below the one we just did. And this is going to be the really easy part. 256 divided by 1 minus a half. Make sure you put that in parentheses. And when we divide that, we have $512.